So far, you've seen how cryptography, through the use of encryption, is used to keep messages safe from prying eyes. Cryptography is also used to verify that data, like documents and images, haven't been tampered with. This is done through a process called hashing. What is hashing? Hashing uses an algorithm, also known as a hashing function, to convert the original text to a unique fixed length value. This is called a hash value. Each time the same text is hashed using the same algorithm, the same hash value is produced. That hash can then be used as a unique identifier of its associated data. Hashing is different to encryption in that it doesn't use keys, and the hashed value can't decrypt back to the original. There are many different types of hash functions. One that's common, and you may hear in discussions with security professionals, is the Secure Hash Algorithm, SHA. SHA is a family of hash algorithms that each work differently. The details are beyond the scope of this content, but one of the more commonly used SHAs is SHA-256, which produces a hash value that is 256 bits long. What is a digital signature? A common application of hashing is in digital signing. Like a signature on a piece of paper, a digital signature validates that the document bears the signature, which actually comes from the person who signed it. Additionally, a digital signature is used to validate that the document hasn't been tampered with. How does a digital signature work? A digital signature will always be unique to each person signing a document, much like one that's been handwritten. All digital signatures use an asymmetric key pair, the private and public keys. Using a digital signing service, Monica can assign a digital signature to the document to prove that it hasn't changed. Signing the document creates a time-stamped hash for it. This hash is then encrypted using Monica's private key. Next, the signing service appends the hash to the original document, which isn't encrypted. Finally, both the digitally signed document and Monica's public key are sent to Victoria. When Victoria receives the digitally signed document, she uses the same digital signing service to extract Monica's hash from the document and generate a fresh hash for the original plain text document. Then, using Monica's public key, the encrypted hash is decrypted. If Monica's decrypted hash matches the one Victoria created for the document, then the digital signature is valid. Victoria then knows that the document hasn't been tampered with. Digital signing requires using a digital signing service. Many companies offer this capability. Two of the most popular are DocuSign and Adobe Sign. The following video demonstrates how digital signatures work and how they show if a document has been tampered with.
Signing is a form of cryptography that does not hide the contents of the document, but proves the identity of the sender and that the document has not been tampered with. This ability to verify the sender and the contents is essential in an increasingly connected world, and it's now possible to legally sign a document electronically using these techniques. While encryption starts by using a public key to hide the contents of the document, signing starts with the person's private key. By using their private key, the individual can prove their identity because no one else has access to that key. Ryan Ingram wants to send a document to Tamika Merrill and prove that he sent it. Ryan signs the document using a publicly available hashing algorithm to create a hash of the document, encrypts the hash using his private key, and attaches it to the document as the document's signature. Ryan then sends the document to Tamika. Tamika can now create a hash of the document using the same publicly available hashing algorithm and decrypt the signature using Ryan's public key. If the decrypted signature matches the hash of the document, this proves that the document has not changed and that Ryan signed it. Let's have a look at what happens when a document is tampered with. Ryan signs the document using a publicly available hashing algorithm to create a hash of the document, encrypts the hash using his private key, and attaches it to the document as the document's signature. Ryan then sends the document, but this time it's intercepted and altered. When Tamika receives the document, she creates a hash of the document and decrypts the signature using Ryan's public key. The decrypted signature now does not match the hash of the document, which proves that either the document has changed and/or that Ryan has not signed it. Either way, the document cannot be trusted.